So this talk is on 3 connected problems from the homework, 4.15, 4.33, and 4.42. It's all the same problem, but we solve it differently, graphically, algebraically, and using simplex tableaus. So what is the problem? 4.15. We want to maximize the objective function z equals x1 plus 2x2, subject to 2 constraints, x1 plus 3x2 is at most 8, and x1 plus x2 is at most 4, with the non-negativity conditions, namely x1 is non-negative and x2 is non-negative. So if we're going to solve this graphically, so this is problem 4.15, solve graphically. So let's say 0, 2, 4, 6, 8, 2, 4, 6, 8. If we look at the equation, x1 plus 3x2 equals 8. When x2 is 0, x1 is 8. When x1 is 0, x2 is 8/3, which is 2 2/3, about there. So if we're looking at the non-negative, everything under this straight line in the first quadrant, it's this triangle. x1 plus x2 equal 4 is just the line that looks like this. So our feasible region is this. And what are the CPF, the corner point feasible solutions? Well, there are 4 corner points: 0, 0, 0, 8/3. This point, if you solve the 2 equations and 2 unknowns, x1 plus x3, x2 equals 8, and x1 plus x2 equals 4. If you subtract, you get 2x2 equals 4. So x2 equals 2. And if x2 is equal to 2, x1 is equal to 2. So this point has coordinates 2, 2. And this corner point feasible solution is 4, 0. So if you estimate, if you calculate z at these points, when x1 and x2 are 0, z is 0. At this point, z is equal to 0 times x1 plus 2 times 8/3, which is 16/3, which is 5 1/3. When x1 and x2 are both equal to 2, z is 2 plus 2 times 2. 2 plus 4 is 6. And at 4, 0, this is 4 plus 2 times 0, which is 4. So this is the maximum value of the objective function, and it occurs, so z equals 6 is the maximum value of the objective function, and it occurs when x1 equals 2 and x2 equals 2. So this is the graphical solution to the problem. In problem 4.33, we want to solve this by using linear programming. So here is the objective function and the two constraints. When we introduce slack variables into the constraints, we get x1 plus 3x2 plus x3 equals 8. When we add a slack variable to the second constraint, we get x1 plus x2 plus x4 equals 4. And from the objective function, we can write this as z minus x1 minus 2x2 equals 0. So we look at this first line and we see their negative coefficients for x1 and x2. The larger negative coefficient is minus 2. So we're going to use this as our pivot column. We look at the ratio, 8/3, 4/1. This is the bigger one of the two. So this is our pivot row. And what we want to do is, by using elementary operations on these linear equations, arrange it so the coefficient of x2 and on this line is 1 and the other coefficients of x2 are 0. So we take this equation, so we can think of this as equation 0, 1, and 2. I want this to be a 1, so I can multiply this whole equation by a third. I get a third x1 plus x2 plus a third x3 equals 8/3. I want this to be a 0, so I can take this equation minus this equation. So x1 minus a third x1 is 2/3 x1. x2 minus x2 is 0. 0 minus a third x3 is minus a third x3. And see, 1 minus 0 is 1. And 4 minus 8/3, 4 is 12/3. 12 minus 8, this is 4/3. And then I want to get a 0 here. So I take this equation and I add 2 times this equation. So I get z minus x1 plus 2/3 x1 is minus a third x1. Minus 2x2 plus 2x2 is 0. 0 plus 2 times this is plus 2/3 x3. And 0 plus 2 times this is 16/3. If I want to keep track of what are my basic variables, when I start, x1 and x2 are non-basic, and x3 and x4, these are the basic variables. After one iteration, x2 has become a basic variable, x3 has left, and x4 is the other basic variables. This is the basic column. Okay, I look at this row, I see there's still a negative coefficient, minus a third x1. So this is my pivot column. And again, I look at these ratios. 8/3 over 1/3 is 8. 4/3 over 2/3 is 2. So this is the smaller of those two ratios. And now this is my pivot row. And this is my pivot place. So I want this to be a 1 and these to be zeros. So in this row, I multiply it by 3/2. 3/2 times 2/3 is 1. Minus 3/2 times 1/3 is minus 1/2 x3. Plus 3/2 times x4. And 3/2 times 4/3 is 2. I want to add a multiple of this line, of this equation, to equation 1 to get a 0 here. So I'm going to take 1/3 x1, multiply this by 1/3 and subtract, which is the same thing as multiplying this by 1/2 and subtracting. But 1/3 x1 minus 1/3 x1 is 0. x2 minus 0 is x2. 1/3 x3 minus 1/3 times minus 1/2 is plus a 6. 1/3 plus a 6 is 1/2 x3. 0 minus 1/3 times this is minus 1/2 x4. 8/3 minus 1/3 of 2, that's 8/3 minus 2/3, that's 6/3, that's 2. And I want to get a 0 here, but there already is a 0 there, so I don't have to, oops, sorry. I want to get a 0 here. So again, I add 1/3 of this line to this line. So I get z minus 1/3 x1 plus 1/3 x1 is 0. 0 plus 0 is 0. 2/3 plus 1/3 of minus 1/2. That's 2/3 minus a 1/6 is 1/2 x3. 0 plus 1/3 x4 is 1/3 x4. Oops, let me just double check. 2/3 x3 plus 1/3, that's minus a 6. 2/3 minus a 6 is 1/2, that's right. 0 plus 1/3 x4 is 1/2 x4. And 16/3 plus 1/3 of times 2, 16/3 plus 2/3 is 18/3, which is 6. And now I have no more negative coefficients here. So I'm done. Here x1 has become a basic variable, x2. So what I have is, so if you said x3 and x4 equals 0, x1 equals 2, x2 equals 2, x3 and x4 are 0, and z, which is x1 plus 2x2, is 2 plus 2 times 2 is 6, just like it says over there. So this is the solution. Exactly what we got by the graphical method. The corner point 2, 2 is the solution, and the maximum value for z is 6. So that's problem 4.33. And problem 4.42 is to solve using a simplex tableau. So what that means is we just take our equations and translate them into tableau form. So here are This is the objective function, and these are the two constraint equations. So I'm going to have the following column: z, x1, x2, x3, x4, and then the right side. And this will be equation 0. The coefficients are 1, -1, -2, 0, 0, 0. In equation 1, there's no z, 0, 1, 3, 1, 0, 8. In equation 2, there's no z, 1, 1, 0, 1, 4. So, and the basic, so this is the equation number. If I want to list in each equation, which is the basic variable, z, x1 and x2 are the non-basic variables, x3 in equation 1 and x4 in equation 2 in this first step are the basic variables. And again, we look at this objective function line. There are two negative coefficients. The one largest in absolute value is -2. So this is going to be our pivot column. When we look at our ratios, 8/3 and 4/1, this is the larger one. So our pivot row is this. This is the pivot number. So now we do our first iteration. You have the second tableau, and it's going to really follow exactly what happened when we worked with the equations. So 0, 1, 2. We got this to be a 1 by multiplying this line by a third. And we get 0, a third, 1, a third, 0, 8/3. And subtracting this line from the bottom line, because we want to have zeros here and here, right? What we get for line 2 is 0z, 2/3, 0, minus a third, 1, 4/3. It's exactly what we get from the equations. And the first line is 1 minus a third, 0, 2/3, 0, 16/3. And x2 is now the basic variable for this line, x4 here, and z. And again, we have a negative coefficient. So we're going to be looking at this column. When we look at the ratios, this is 8/1, this is 4/2, that's the smaller. So this will be the pivot row, and this is the pivot element. And So these are the 0, first and second equations. We want this to be a 1. We multiply this by 3/2, just as we did with the equations. And we get 0, 1, 0 minus 1/2, 3/2, 2. And then we take this line minus 1/3 of this line, and we get just what we got when we were dealing with the equations. 0, 0, 1, 1/2 minus 1/2, 2. And when we eliminate this minus 1/3 by adding 1/3 of this line, we get 1, 0, 0, 1/2, 1/2, 6. And now you see, so z, x1 has entered as a basic variable, sorry, here, and x2 here. There are no negative numbers in the z line, so we're done. So we have our non-basic variables, x3 and x4 equal 0. When x3 and x4 are 0, x1 is 2 and x2 is 2. And the value of z is 6. So again, we get exactly what we got using the graphical method. And that's what it is. Okay, so much for those 3 homework problems.